வணக்கம் ஸ்டூடெண்ட்ஸ். இன்னைக்கு நம்ம ஒரு சூப்பர் இன்ட்ரெஸ்டிங் அண்ட் ரொம்ப இம்பார்ட்டன்ட் டாபிக் பார்க்க போறோம். Physical properties of diazonium salts. பார்க்க சிம்பிளா தெரிஞ்சாலும் இதுல ஒரு நல்ல கான்செப்ட் இருக்கு.
ஓகே, லெட் மீ ஆஸ்க் யூ அ கொஸ்டின். நம்ம வீட்ல யூஸ் பண்ற சால்ட், டேபிள் சால்ட், அதாவது சோடியம் குளோரைடு, அது எவ்வளோ ஸ்டேபிள், ரைட்? இயர்ஸ் கணக்குல அப்படியே வச்சிருக்கலாம், ஒன்னும் ஆகாது. பட் நீங்க என்ன நினைக்கிறீங்க? கெமிஸ்ட்ரியில இருக்கிற எல்லா சால்ட்ஸும் அப்படி ஸ்டேபிளா இருக்கும்? இங்க பாருங்க. The difference is huge. On one side, we have our familiar table salt, which is super stable. On the other side, we have this diazonium salt, which is highly unstable. I mean, so unstable that you have to prepare it and use it immediately. Ithadan the big surprise, right? It's a salt, but it's not stable at all. So, the big question is, why? ஏன் the salt மட்டும் இப்படி behave பண்ணுது? Why can't we just store it in a bottle like other salts? Let's get to the bottom of this. Okay. So, at the most basic level, ஒரு diazonium salt is just an ionic compound. அதுல எந்த கன்ஃபியூஷனும் வேணாம். ஆனா, here's the twist. It's also thermally unstable. சிம்பிளா சொன்னா, ஹீட்டை பார்த்தாலே இதுக்கு ஆகாது. It just breaks down.
So let's zoom in and see what's really happening at the molecular level. First, since it's an ionic compound, அது waterல நல்லா dissolve ஆகும், that's expected. ஆனா, the real hero of this story is the N2+ group. You know, this group is what we call an excellent leaving group. It's just desperate to get out. Why? Because வெளிய போனா, it becomes nitrogen gas, N2, which is super stable. So all it needs is a little bit of energy, கொஞ்சம் heat, and poof, it escapes. இதுதான் its instabilityக்கு main reason.
Okay, to make sure you never ever forget this concept, I have the perfect analogy for you. Ready?
Just imagine this. ஒரு grenade with the pin already pulled. நீங்க அதை எவ்வளோ கேர்ஃபுல்லா ஹேண்டில் பண்ணுவீங்க? The slightest jolt, a little bit of movement, and it could go off, right? That's exactly what a diazonium salt is like. It's packed with energy, just waiting for a reason to decompose.
So, this property has a formal name, thermal instability. It just means that a substance has a tendency to decompose when heated. For diazonium salts, this isn't just a textbook definition. It's the key to their entire chemistry. It explains why they're so reactive and why we have to prepare them fresh and use them on the spot in the lab. So, we have this unstable grenade. Does that mean it's useless? No way. In fact, it's incredibly useful, if we know how to control it. So, how do we control this explosion? The secret is temperature. Okay, picture the speaker with me. First, we place the diazonium salt solution in an ice bath, right, at 0 degrees Celsius. Inagum. Nothing. The N2+ ions are calm and the solution is stable. Now let's take it out and just leave it at room temperature, say around 25 degrees. Now the ions are getting a little bit of energy. You'll start to see tiny bubbles of nitrogen gas. The decomposition has started, but it's slow. Okay, now let's heat it up, above 50 degrees. Whoa. Ipaparanga, you'll see vigorous bubbling, with lots of nitrogen gas rushing to escape. See? Temperature acts like a control switch for this reaction. And that brings us to the most important number in this entire topic. 0 to 5 degrees Celsius. Please remember this range. This is the magic window for working with diazonium salts. And where do we see this magic window in action? In a huge everyday application, the dye industry. Think about all the colorful clothes we wear. Many of those colors are made using these reactions. So, what they do is they keep the diazonium salt in this 0 to 5 degree range. At this low temperature, it's stable just enough for them to use it in the next reaction, the one that actually creates the color. It's like a race against time, and controlling the temperature is how they win. All right, let's bring it all together. Here's a quick recap of the most important things you need to remember for your exam. So, just 3 simple things to lock in your mind. Number 1, the core idea. Diazonium salts are ionic compounds, but they are thermally unstable. Number 2, the mental picture. Just think of that grenade with the pin pulled. And number 3, the real-world example, the dye industry, where they use that magic temperature of 0 to 5 degrees Celsius to control its reactivity. And that's pretty much it. If you just remember these 3 points, the core idea, the grenade analogy, and the dye industry example, this entire topic becomes super easy. In the Muna point samtiranja, physical properties of diazonium salts topic examla Roma Laida Filago. You've got this. All the best.